For our visitors, welcome to the Indian Ocean Marine Research Center. I'd like to pay my respects and acknowledge the traditional custodians of this land, the Windar people. My name is Jessica Benthuysen. I'm a physical oceanographer at Ames, and I'm a sub-facility leader for sensors on tropical research vessels. If we have an emergency, you will hear an alarm, and you are requested to kindly exit the building in an orderly fashion. Today, we have a special guest with us, Dr. Grant Smith from the Bureau of Meteorology. He's here to tell us about the seasonal forecast for waters off Western Australia for 2019. First, I'm going to be giving a very short overview on some of the latest understanding and tools for temperatures off Western Australia. Then I'll introduce Grant, and he'll be giving a 30 to 40-minute talk and then answer your questions. Let's get started. I'd like to start off by talking about the current state of temperatures around Australia. These are the three temperature anomalies from IMOS Ocean Currents. IMOS Ocean Currents is updated daily, and it provides a picture of the sea surface temperature anomalies with respect to a very recent climatology known as the Sea Surface Temperature Atlas of Australian Regional Seas. And what we find is that south of the Northwest Cape, there's cooler waters than usual. Into the Northwest Shelf, there's neutral or slightly warmer conditions. And also in the Tasman Sea and extending into the Great Australian Bight, there's much warmer temperatures. We're here today because we want to know how these patterns, these warm temperature patterns, will change over the coming months. We want to know how high these temperatures will reach. Every summer, we look very closely at these sea surface temperature anomaly patterns because we know the effects of extremely warm temperatures and how they can harm our marine ecosystems. In the past decade, we've had a number of unusually warm water events affecting our coastal waters, in particular, the 2011 event. These events have been referred to as marine heat waves. The 2011 marine heat wave was caused predominantly by one of the strongest fluid current speeds on record, bringing all this warm tropical water south along the coast. It led to temperature anomalies of over 5 degrees, and that had a devastating impact on our marine ecosystem. And it led to a reduction in seaweed canopy cover, invertebrate and fish kills, and also this southward shift in tropical species along the coast. Now, after this event, several years later, so in January 2015, almost exactly 4 years ago today, we realized that we needed to have a physical framework for understanding these unusually warm water events. So Thomas Wernberg here at UWA and other colleagues at University of Tasmania organized this workshop in the Oceans Institute in the previous building, not too far from here. And this brought together ecologists, oceanographers, and atmospheric scientists. And together we realized that the atmospheric science community had a well-developed framework for understanding atmospheric heat waves, but the oceanography community lacked a way of quantifying them. So the purpose of this workshop was on the physical drivers and properties of marine heat waves. And from this workshop, we developed a definition for a marine heat wave. A marine heat wave is a discrete, prolonged, anomalously warm water event at a particular location. So anomalously warm means that temperatures exceed a 90th percentile climatology. Prolonged means that these conditions persist for at least 5 days. And discrete means that this event has a well-defined start and end time. So using this definition, we now had a way of identifying and also quantifying these warm water events. And along with this definition, there's some code that's been written in both R and in Python, and it's freely available for you to use to calculate these different metrics. And that code is available on this website, marineheatwaves.org. So go ahead and check out the website. Now, 1 year later, after this workshop, we had this mass coral bleaching event that affected waters across tropical Australia. And that was associated with this marine heat wave in 2016. But now we had this framework for quantifying what was happening during this event. And this includes the intensity or the SST anomaly above that climatology, as well as duration, how long this marine heat wave lasted. And what we found for Southeast tropical Indian Ocean is that the waters experienced the most intense and longest marine heat wave on record. And there are others in this center who are actively investigating the coral bleaching events during this time period. So now we have this definition for a marine heat wave. The next step is how can we compare different events in time and in space? So just last year, we developed this definition, this way of naming and categorizing marine heat waves. So we have this way of naming and categorizing marine heat waves, just like we have a way for naming and categorizing tropical cyclones. But in contrast to tropical cyclones, we don't actually name them by a person's name. We simply consider the year as well as the regional location in which that marine heat wave occurs. So very simple. And to consider the categorization, let's consider this example. So we have a sea surface temperature time series, that's a dashed line. Comparing it to a climatology, that's the bold line. And we look at that 90th percentile threshold, so that's a thin line. And we simply take the 90th percentile minus the climatology, and we consider multiples of that, 2 times, 3 times, 4 times, and that gives us these categories. So 1 through 4, from moderate, strong, severe, and extreme. So in this example, that temperature time series extends into category 4. This would be an extreme marine heat wave. Now that we have this method of categorizing marine heat waves, we can place into context the past events in 2011 and in 2016. So in the top, you're looking at the categorization from the 2011 event. The temperatures are reaching at 5 degrees above climatology. That's going into category 4, extreme, the highest category that can be reached. Now in 2016, we have a very different picture. So off of WA, adjacent from here, there wasn't any marine heat waves. But if we look up along into the Northwest Shelf, there are wide portions that are actually categorized as severe, number 3. So one of the things this year that I will be working on with Grant is to implement this categorization system into the Bureau's seasonal outlooks. So please stay tuned.